Okay, so now we're going to go on to geometric proof. Okay, this can look very daunting, and at first glance, it looks fairly complicated. But if you look at it in closer review, it's not that bad. Okay, so let's look at geometric proof. Let's go to page 110. Okay, there's a little flow chart there in the middle. It says, from the hypothesis, you're going to the conclusion. Okay, so you're trying to prove something geometrically or using geometry. You're going to try to prove something. In the middle, you have at your disposal the four things. You can use either definitions, postulates, properties, and theorems to get you from the hypothesis successfully to the conclusion, okay? So that's what you're trying to do. Again, just like we do with the algebraic proofs, we're going to label or make sure each step has a logic to it, okay? So let's go to example number one. Example number one, we have, write the justification for each step. Given that A and C are complementary, and A and C are congruent, okay, we're going to get from there to, we're going to try to prove that C and B are complementary, okay? So we have that angle A and B are complementary, okay? We have this, A and B are complementary, okay? And where do we get that information from? We got that information because it was given to us. It's a given, it was given in the question, okay? And then we're gonna say that since this is true, the angle measure A plus the angle measure B is gonna be what? It's gonna be 90 degrees, right? That is the definition of complementary, right? So this is a definition. It's a definition, right? But then I'm given that angle A and angle C are congruent. Again, this is a given in the question. Okay. So now I can say that what? Angle A is equal to angle C, right? And this is what? This is the definition, right? This is the definition of congruence of an angle, right? Because the angle is congruent, which means that the angle, the measurement has to be the same, okay? Now I can go ahead and say what? Since A and C are the same, I can substitute this into here, and I can say that angle C plus angle B are 90 degrees, right? It's going to equal to 90 degrees, right? And we're just substitution. This is substitution, right? Substitution, property of equality, right? Okay. So therefore, angle C and angle B are complementary, right? And this is again a definition, right? This is a definition of this, right? Definition of complementary says that this has to happen. Okay, right? Again, notice that we are not doing anything that's really robustly hard, right? What we're trying to do is, all we're doing is we have to label each step and tell everybody what my logic from this step to this step is, okay, from each step, okay? So we were given this, and then from here, this is the definition of complementary, right? And then I've given that also A and C are congruent. Therefore, the angle measures are congruent by the definition, right? And I can substitute this from here, right? Here to here. I'm substituting, and that's the definition for complementary. And this is what we were trying to prove. Okay, again, this was, so I had, this is the conclusion that I was trying to get to, right? Okay, but each step has a label, has a logic, has a reason. Okay? And that's the whole exercise of this. Okay? Because if you think about it, I mean, it's really quite simple, right? What you're trying to prove here, right? But it's having to label each step makes it a logic, more of a logic. So it gives you each step of what we're trying to do, and it becomes black and white, very concise, very well defined what we're doing. Okay. Now let's go to a theorem on the very last page, on the bottom of page 110. There's a theorem there that says linear pair theorem. If two angles form a linear pair, then they are supplementary, right? Linear pair is what? A linear pair is where you have two adjacent angles that add to 180 degrees, right? Okay. So this would be a linear pair, okay? If I go in like this and had an angle like this, A, B, C, D, angle AOB and angle COD are not linear, right? Because they do not share a side, okay? So this would not be, although angle AOB and angle COD are still going to be supplementary because they add at 280 degrees, all right? But they're not a linear pair, right? In this instance, we're talking about a linear pair. So they have to share the side, okay? They have to share a side like this, okay? So if they share a side, so linear pairs are supplementary, okay? Which makes sense. And on top of page 111, there's another theorem, congruent supplements theorem. If two angles are supplementary to the same angle for two congruent angles, then the two angles are congruent, okay? So if I had angle, they went like this, I said this is angle number 1, and this is angle number 2, and this is angle number 3. I know that angle 2 and angle 3 are the same because they are vertical angles, right? They're vertical angles, okay? But I know that 1 and 3 are supplementary because they add to 180 degrees. And I know that 1 and 2 are supplementary, okay? So in that case, 2 and 3 would be congruent is what they're saying, okay? Although they were labeled differently in the books, that's the same concept here, okay? So let's see if we can do example number 2. In example number 2, we're going to have what? Fill in the blanks to complete a 2-column proof. Okay, so these are the type of questions that you will see on the test. You will see a 2-column proof that is incomplete, and you have to follow the logical where we're going. You have to find where we're going and what each step is, where it comes from. Okay, so fill in the blanks to complete the 2-column proof of the linear pair theorem, okay? So given angle 1 and angle 2 form a linear pair, angle 1, angle 2, okay, given that 1 and 2 form a pair, prove that 1 and 2 are supplementary, okay? So number 1, it says angle 1 and angle 2 form a linear pair, and that's a given. And then we have ray BA and BC form a line. That's the definition of a linear pair. And then we have number 3, angle ABC is equal to 180 degrees, definition of a straight angle. Okay, then we have 4, we don't know what, but it says the addition postulate. So we're gonna add, looks like we're gonna add something to both of them, right? So what are we going to do? We're going to say that angle ABC, this angle linear angle, is the angle 1 plus angle 2, right? So we're going to say that the angle 1 plus the angle 2 is going to be the same as angle ABC, right? Then B, we substitute steps 3 and 4. So we're going to substitute this guy. We know this is 180 degrees, right? We know this is 180 degrees, okay? And then we're going to say what? We're going to leave this guy here. Since I know this is 180 degrees, I'm going to substitute that, and I already proved that in step 3, right? In step 3. Okay, so I have this. Now this is a definition of supplementary, right? So that would be number 6. 1 and 2 are supplementary by the definition of supplementary, right? Definition of supplementary angles. Okay, so again, you just have to read through the proof, see where they're going from and where they're going to. And even within that going from and going to, each step is kind of logically makes sense. You have to follow the strain or the thread to where we're going. Okay. Flip the page, go to page 112. On page 112, we have what? Page 112, there are another theorem, couple theorems there. 2-6-3, right angle congruence theorem. All right angles are congruent. That makes sense, right? Because by definition, a right angle is an angle that is 90 degrees. So anything that is 90 degrees they're all going to be congruent, which makes sense. Then we have 2.2-6-4, congruent complements theory. If two angles are complementary, which means that they add to 90 degrees, if they are complementary to the same angle or two congruent angles, then the two angles are congruent. Okay, again, it's the same thing. If I have 90-degree angle that's formed here, and I have a 90-degree angle that is formed here, okay, what they're saying is if 1 and 2 are complementary, and 2 and 3 are complementary, in other words, angle 1 plus angle 2 is equal to 90 degrees because they're complementary, and angle 2 and angle 3 are complementary, that means that angle 1 and angle 3 are congruent. They're the same. Okay. Okay, so that's that. Let's go see if we do example number 3. Example number 3. Use the given plan to write a 2-column proof of the right angle congruence theorem. Given that angle 2 are right angles, okay, prove that they are congruent, okay? So the plan is to use the definition of a right angle to write the measure for each angle, then use the transitive property. Okay, remember the transitive property? If 1 is equal to 2 and 2 is equal to 3, then 1 is equal to 3. Okay? Use the transitive property and the definition of congruent angles. Okay? So you're going to say that first, angle 1 and angle 2 are right angles. Okay? And this is a given. Okay, we're given that, which means that what? The angle 1 is equal to 90 degrees and angle 2 is equal to 90 degrees. How do I know that I use this step? Because it tells me in the plan, right? It says, use the definition of a right angle. So I'm using the definition of a right angle to prove that, okay? So 90 degrees, and this is the definition of a right angle, right? This definition of a right angle, okay? So I know that, so that means that the angle 1 and angle 2 are the same, okay? And then what? So this is the what? This is the transitive property, right? Because this is equal to that, this is equal to that, therefore these two are equal to the same, right? So this is the transitive property. This is the transitive property. And since these two are the same, that means that angle 1 and angle 2 are congruent. And this is another definition, right? Okay. So again, you have to start to follow the thread and and this one is like, it gives you the playbook. It gives you how to go about doing it. You just need to follow it step by step and be able to label each step for the logic behind each step. Okay? Again, this is something you'll get better at, and feels kind of ambiguous. Looks kind of hard, but once you do a couple of them, they should become more familiar. Okay. All right. So that's